So this was an exercise assignment which was related to chromatography and spectroscopy. I'll discuss the doubts related to this exercise. The first one is page number 4, question 2A, 1, 3, and B. So this one is page number 4, and the doubt is from question 2, part A, and as well as part B. So the first part, pre amino acids are shown, but obtained by hydrolysis of the protein. So when we do hydrolysis of the protein, 3 amino acids are there. Draw the zitronine of alanine. So what does it mean? It means like one molecule will have both positive and negative. So it means one side it will lose proton and another side will gain proton. Like NH2 will gain proton, it will become NH3, and the charge will be plus, and COH will lose its proton, so it will have a negative. That is for amino acids, that is known as zitronine. So a species formed when valine is dissolved in alkaline solution. Look, when it dissolves in alkaline solution, what will happen? Like alkaline solution will have more OH ion. So that OH ion will accept, because like acid will react with the alkali. So the part which is acid, that part will react with an alkali. So as a result, what will happen? Like there will be a reaction. So this part only will lose its proton during a reaction. So what will be the product? It will be NH2, CH is there, then CH, then we have CH3 bracket 2, and then CO negative. Because when it is dissolved in alkaline solution will have more hydroxide ions. These hydroxide ions will react with an acid. They can, because hydroxide, it's not an amphoteric, so hydroxide cannot react with a base. So as a result, it will react with acid part only. So the part which is acid for amino acid like COOH is the acidic part that will react, or it will lose its proton. If there was the same question, like if it was in acid, then which part will react? So this part will react. This is an alkaline part, so it will accept proton from the acid. Like the next part is draw the species form for at a low pH. So at a low pH, because this is the alkaline part of amino acid and this is the acidic part. So low pH means like it is in acidic condition. So acidic condition, which part will react? Alkaline part will react. And how alkaline part will react? What is the definition of base? Bases are proton acceptor. So this will accept proton from the water. As a result, it will accept proton from the acid. So as a result, what will become? It will become NH3 plus. The only difference, like this will be NH3 plus. And here what happened? Because it was in alkaline medium, so this part was reacting. And the zitronine in a neutral solution, one side it lose proton and another side it gain. So this will become plus and this become minus. That is known as zitronine. Is it clear? Part A. In part B, draw two dipeptide formed by the reaction of alanine and valine. So two peptide, like having a peptide group, what will happen? Amine will lose its, because one side is H and another side is OH, like they will link with each other. So how we can sorry, how we can link them with each other. We want to form a amide or a peptide linkage. So how amide or a peptide linkage will form here? So this will lose its OH and this will lose its one of the H, not both, one of the H will be lost. So as a result, what will be the structure? We have like here NH2, then C, H is there, and then CH3 is there. And this OH is removed, so this is C double bonded with O. And one of the hydrogen is removed, so NH is there, which is a amide or a peptide linkage. Then we'll have H, CH, CH3 in a bracket 2, and then C double bonded with O and OH is there. This is one of the molecule which is formed. Other way around, how it will form? Like, because in the question they mentioned what we have to do. We have to draw the two dipeptide formed by the reaction of alanine and so what are the two dipeptides are formed? Like two molecules can be formed. So first one, you will take alanine first and valine after. The second one, you will start with valine and end at alanine. This is how the two will form. We don't have to draw a polymer. We have to draw two dipeptides molecules. Like one is alanine with valine, another one is valine with alanine. If first one, if you're forming, we'll remove OH from here and H from here. The second one, when we form, we'll remove OH from here and we'll remove H from here and link them together. Is it clear? You don't have to draw a polymer, you have to draw two different dipeptides. Is it clear, part B? Okay. Name a suitable method by which mixture of amino acids formed by hydrolysis of the proteins are separated. So if you want to separate them, what we use chromatography. So this was page 4. Next is page number 12. These questions are about different isomers of C6H12 and O2. Draw the structure of two esters that both have only one peak in their proton NMR, and these peaks have the ratio 3:1. So this was question 6 continuation is there, and the doubt started from part to okay C part basically. So we have to draw the two esters. So to be an ester, there will be C double bonded with O and O should be there. So first thing, to be an ester, there should be C double bonded with O and O, and this also C double bonded with O and O. Then they only have two peaks in their proton NMR, like two hydrogen environments are there. And the ratio of the peak is 3:1. Like if one side we have three hydrogen, other side one hydrogen, or one side we have six hydrogen, other side two hydrogen. If one side we have nine hydrogen, other side will be three hydrogen. But the peaks, there should be only two peaks. So for this one, like, and the molecular formula, as I mentioned in the beginning of question, the molecular formula is C6. Like, we can have maximum 6 carbons. So this will be 2, 1, 2, 3, 4, 5, and then 6 here. This will have 3 hydrogen. This will have 3 hydrogen. This will have 3 hydrogen. This will have 3. So these are the identical hydrogen environments. I can say that as A, and this is like the same hydrogen identical. So two hydrogen environments are there, and the total number of hydrogen, one hydrogen environment there are 9 hydrogen, and the other hydrogen environment there are 3 hydrogen. So the 9 and 3, the ratio will be 3:1. So this ratio will be 3:1. This is one possible. Then what is the second possible structure? You can switch other way around, like you can have 4 carbon atoms here. You can have 4 carbon atoms here and 1 carbon atom other way around. This will be CH3 and this, and if I say this is A, this one is B, like they are all identical. So A and B, the ratio again 1 is to like 3:9, or you can also say 1:3. So it's the same thing. Like you draw both. Then the next part, draw the structure of optically active carboxylic acid with the 5 peaks in its carbon 13 NMR spectrum. No, both esters are not same. These two esters cannot be same. How these two esters are same? Because when we name the ester, this will be methyl, and there are 1, 2, 3, like it will be 2,2-dimethyl propane. And here this ester will be 2,2-dimethyl ethyl, and then this will be 2 carbons, so it will be ethane. So these two esters cannot be same. How they are same? Because here one side oxygen with oxygen CH3 is attached, and another one carbon is there with the 3 branches. So they are not same esters. They are two different esters. Because like if I have CH3, if I have CH3, C double bonded with O and CH3, or CH2, CH3. And if I draw other way around, like example, I draw OCH3 and then CH2 and CH3 other side. So these two are not identical esters, they are different esters. Then draw a structure of optically active carboxylic acid with a 5 peak is in its carbon 13 spectrum. Look, carbon 12 is not magnetic, like it is not affected by magnetic field, but carbon 13 is affected by magnetic field. And we have to draw, like there is a peak. So we have to draw the structure of optically active carboxylic acid. So the carboxylic acid, which is optically active, means like when a plane polarized light is there, it is affected by the plane polarized light. And with the 5 peaks in its carbon 13 spectrum, like it is having 5 different carbon environment. Because with a 5 peak in its carbon 13 spectrum means like 5 different carbon. So first we draw C like 5 carbon with a different environment. So first we draw C double bonded with ONOH because it's a carboxylic acid, so there should be C double bonded with ONOH. And because the question is a continuation, so we have to draw like according to the 6, as I mentioned here in the beginning, the molecular formula of the P. What was the molecular formula of the P? The molecular formula for the P was C6. So we have to arrange 6 carbon atoms because like we are proposing the structure. So 6 carbon atom, if I arrange 6 carbon atom in this manner, like say in a straight line. 1, 2, 3, 4, 5, and 6. So this is CH3, this will be CH2, this will be CH2, this will be CH2, this will be CH2. So this will be, if we talk about carbon environment, because carbon 13 environment, not hydrogen. This carbon is different from rest, so this is one carbon environment. This carbon is different from other because one side CH3, other side CH2. This another environment. This carbon is different. One side CH2, CH3, other side CH2, CH2, and so C, D, E, and this one is also their F. So it means it has six environment, but we want five carbon environment. Like, so it means it is not a straight chain. If it was a straight chain, then six carbon environments are there, like six carbons which are having different environment. So if I make the branches, one, two, three, four, five, and then six. So this is CH3, this CH3, this will be CH, this will be CH2, this will be CH2, and then now how many carbon environments are there? Carbon environment, like these two carbon are identical, so this is count as one environment. This is second environment, this is third environment, fourth environment, and fifth environment. So this shows like five environments are there for carbon. Is it clear, this one? Then draw the structure of a cyclic compound which has only two peaks in its carbon 13, like it has two different carbon environment and no absorption of C double bonded with O in an infrared spectrum. Means it does not have a like carbon, it is not a carbonyl group, like there is no C double bonded with O. And you have to draw a cyclic compound and it has two peaks, means two different carbon environments are there. So if you want to draw a cyclic compound, first with the six carbon, look, if you draw a cyclic compound with the six carbon atoms, say one, two, three, four, five, six, and then they will have CH2, 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 CH2. This is a cyclic compound. But because of molecular formula, we need oxygen as well, and we need two oxygen according to a question. If I talk about this one, this has all the carbon environments are identical. But if I attach oxygen, like if I attach like because one of the bond will break, and if we attach OH here, and if we remove one of the hydrogen and attach OH here, now how many carbon environments are there? If you check this one carbon environment, even these two are not identical carbon environments. Why they are not identical carbon environment? Because this one is 1, 2, 3, 4, and then 1, 2. But for this one, like when you check the surrounding, like here one and then next. For these, yeah, for these two, yeah, same. Sorry, these two will be same. But when we talk about other carbon, this will be another environment. Like this is A, this is carbon B, this is carbon environment C, carbon environment D, and carbon environment E. So there are like five different carbon environment. So it means the OH cannot be attached here. So where I should attach OH, I should attach OH in the manner so that it should have a symmetry. Because if I attach OH anywhere, the carbon environments won't be identical. So if it is OH on this one and OH on this one, now you can see like this will be CH2, this will be CH2, this will be CH2. So these all are identical. Like these two are identical environment. Like next is CH2 and then CO is there. This one next to C. So same thing for, so these four are identical carbon environments. So this is count as A. And then this one, when OH is attached with C, this is counted as the second hydrogen environment, so we can refer that as B. And there is no C double bonded with O group. Is it clear? This third part? Why we did not attach to any other, like why it's always on the adjacent one? Because if I attach with any other site, as a result, what will happen? It won't have the same surrounding like other carbon atoms. Their environments will be different. So as a result, it won't give two peaks. It will give multiple peaks. When OH are attached to opposite side of the molecule of a cyclic ring, the carbon within the ring are identical. As a result, it will give a single peak because of them. This was page 12, then page 13, part B. Compound C and D have a molecular formula. In their NMR spectra, C has three peaks and D has only one peak. So we want to draw three peaks, means like three different hydrogen environments are there. And one peak means like only one hydrogen environment is there. And we have five carbon. So five carbon, if I need one hydrogen environment, like it will be all CH3 attached to carbon. This is very easy one, like all are identical hydrogen environments. What about the other one? We need three peaks. First, if I draw a straight chain here, CH3, CH2, 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 CH3. When we talk about the peaks, like this is A, identical. Then CH2 is there. With CH2, this is B. And this one is C. So A, B, and C, like three peaks are there. With a ratio will be 6, because total A and A 6 are there. 4 and 2. So it will be 3, 2, and 1. So this was page 13, part B. Then part C as well. Compound E and F are both esters with their NMR, and there's a quartet. Quartet means like four are there, four peaks. And F has a quartet at 4.1. So for this, you have to use a data booklet to identify like what 2.3 parts per million and 4.3 ppm shows, like what it suggests according to a data booklet. Which group is there? So we have 4.3, 2.3, and 4.1. And nuclear magnetic, page 7. Here, I'll just zoom out. So according to data booklet, 2.3. What should be there around 2.3? Means 2.3 will be somewhat here. So 2.3 shows like aldehyde, ester, amide, in which the C double bonded with O is attached with carbon chain. Like carbonyl group is attached to a carbon chain. Or it can also be when alkenes or arenes are there, a carbon like a CH, a carbon attached to arene, or carbon double bonded with carbon. And what about 4.3? So when you draw a line from 4.3, what it shows, it gives idea that this might be due to a benzene ring attached to arenes, or OH group is attached. And we have four carbon atoms, like we have to arrange four carbon atoms, and has a quartet. Quartet means like neighbor is having three hydrogen, because if neighbor is having three hydrogen, it will give a quartet because n plus one. And this also quartet means neighbor is having three hydrogens. So when we draw the structure, like first we identify that C double bonded with O is there. So for question 7 part C, so C double bonded with O, and O is there. And according to data booklet 2.3, so C double bonded with, but the arenes you did not study, so it means and there will be a CH groups, like with C double bonded with O, and with a carbon there's a CH group is attached. That is giving a peak. So there's a CH group attached with a carbon. Sorry. So C double bond, and we want to arrange a four carbon atoms. So 2.3, aldehyde, ketone, ester, or amides are there. C double bonded with O, and a group attached with CH. And this one is when with oxygen. 4.3 also about this one as well. Like with alcohol, esters or ethers, if a carbon is attached with oxygen, that will give a peak around CH, around 4.3. So when we draw the structure, the possible structure for E, like if I say, because we want to arrange four, if this was CH3, this was CH2, and this was CH3. Or when we check the peak, like this is C double bonded with O, and O is there. So like this is a carbon which is like this is the one which is giving a peak at 2.1, because if C double bonded with O and O, and CH group is attached, it can be CH2, it can be CH3, it can be CH as well. But this group is responsible for giving and they mention that this is giving quartet. If this is giving quartet, the neighbor should have three hydrogen. So here the neighbor does not have any hydrogen, so other neighbor should have three hydrogen. So this will be CH3. So what does it mean? Means this should be CH2. And then remaining, we will have CH3 here, because four carbon atoms. So we identify from the data booklet that a peak at 2.1 is the peak when a carbon CH or CH2 or CH3 is attached to a carbon of C double bonded with ONO. So this carbon is 2.1 carbon, and that is giving us the peak, and it is giving a quartet, so means its neighbor should have three hydrogen. Right hand side neighbor does not have any hydrogen, so the left hand side neighbor should have three hydrogen, because 3 plus 1 will make 4. So that's why it will give quartet. Is it clear? The structure of E. Any doubt in the structure of E? Then the next one is 4 point, sorry, it was 4.1. I thought 4.3. Yeah. So 4.1, when you check 4.1, you draw a line from 4.1, it will be about 4.1 like this. So What does it mean? 4.1 means when with oxygen, oxygen of alcohol or oxygen of ester, if a carbon is attached with the oxygen of ester, oxygen of alcohol, that will give us this peak of 4.1. So means it will be C double bonded with O and O. And this side now, this one is giving like CH is there. It can be any, like CH is their example. This will give us a peak of 4.1 and it is giving quartet. So if this is giving a quartet, the neighbor should have 3 hydrogen. This is having 0 hydrogen, so the other side of this one should have 3 hydrogen. And this cannot be then CH, it should be CH2 because the number of the bonds carbon maximum form 4 bond. Then this side will be CH3. So this is a second proposed structure of, like this, a structure of F. And the two esters are different from each other. The two esters are different from each other. How we identify they're different? Because one is like methyl ethanoate, another one is ethyl methanoate. So this was page number 13 and page 17. Page number 17, the doubt is part D and E. This is question number 8. Okay. And page 17. Outline the mechanism of reaction 3. Mechanism of reaction 3. Reaction 3 is reaction 3 is a substitution reaction. Like ammonia, it's a NH2 group is added and the Br is being removed. So this will be partial negative. It is a nucleophilic substitution. Then NH2 group is there. With a lone pair, it will attack on the positive center and the bromine will break the bond. Bond breaking and a bond forming will take place at the same time. Or it's a secondary. So first the bond will break, then the bond will form. Or it can be SN1 like nucleophilic because primary is always SN2. Sorry, primary is like what will happen, the bond breaking and bond forming, yeah, SN2 is there with the primary. And for tertiary, first the bond will break and then the bond will form, it will be SN1. But for secondary, you can draw both ways. You can draw SN2 or you can also draw SN1. Like first you will break the bond and then the new bond will form. This is related to AS. And the next part is state the condition used in reaction for a maximum amount of a primary amine. If we need a maximum amount of primary amine, again, the AS condition, like we should use excess of ammonia. If a limited supply of ammonia is there, then it will give secondary amine or multiple hydrogen, multiple times it will be hydrogen is removed. So as a result, so we need excess of and draw the structure of secondary amine form as a byproduct of a reaction 3. So say just what you will do, like the two hydrogen sorry sorry so what you will do, like you will replace the two hydrogen with a carbon chain of ammonia. Like here when NH3 is there, NH2, this will become NH. Now what will happen? One of the again another hydrogen will be removed and the carbon will be attached here. CH2, CH3. and then CH2, CH3 will be there, and H. That will make a like one of more hydrogen remove, and the carbon chain will attach with a nitrogen. Draw a primary amine which has a three peaks in its carbon 13. And isomer of a D is also a primary amine and also have a three peaks. Draw the structure of isomer of D. Three peak carbon 13 means like three different carbon environments are there. So we want to draw the three different, and D is also isomer of a primary amine. So it's an isomer. So isomer of primary amine is there. So to be a primary amine, what does it means? Like NH2 should be attached with a carbon which is having hydrogen. That is the case. Because they mention it's a isomer of like NH2 group. This will always be there. Only thing will what will happen, the carbons which are attached, that will be different. And we have in the question, we have how many carbon environments are there? Three carbon environment. So if we draw CH3 here, CH3 here, and CH3, so this will be one carbon environment. This will be the second carbon environment. This is the third. So three carbon environments will be there. It is a primary amine, and it also have a three peak of carbon 13. Mean if I draw a straight chain, like example, if I draw NH2, then NH2 and CH2 will be there. But if I draw all of them in a straight chain, like CH2, 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 and CH3, so this is one carbon, second carbon, third carbon environment, four, five peaks will be there. That's why this is not the possible. Then another isomer of a D is tertiary amine. What is the meaning of tertiary amine? Like amine group is there attached with a carbon, and this carbon should have three carbon chains. And it has three peaks. It has three NMR spectrum, three peaks, and one of there is a doublet. So to be tertiary, like carbon chain should be attached. And how many carbons we have? Like we have so if you check this one, this proposed structure, because one, two, three, four, five carbon we need. So if I remove this hydrogen and attach CH3, 1, 2, 3, 4, 5 carbon. And this will be hydrogen. So if we check 1, 2, 3, so this will be, according to a question, three peaks are there. This is one hydrogen environment, this another hydrogen, this another. And one of the peak is a doublet. So this one will be a doublet. How? Because this next to that is NH, and so this will be a doublet. This is one proposed structure. There's also another proposed structure is there that was in the marking scheme. The structure they do directly attaching like all the carbon directly, like all of the hydrogen are replaced. Because this is also tertiary. Tertiary amine means like all of the hydrogen are replaced by, but usually like primary alcohol. So this is also another proposed structure. If you see, this will have like one hydrogen environment. This is a second hydrogen environment. This is a third, and this will also give a doublet. So this is also correct. Is it clear? This was the last, I think.